Electricity is the set of physical phenomena associated with the presence and flow of electric charge. Electricity gives a wide variety of well-known effects, such as lightning, static electricity, electromagnetic induction and electric current. In addition, electricity permits the creation and reception of electromagnetic radiation, such as radio waves. In electricity, charges produce electromagnetic fields which act on other charges. Electricity occurs due to several types of physics. Electric charge, a property of some subatomic particles, which determines their electromagnetic interactions. Electrically charged matter is influenced by, and produces, electromagnetic fields. Electric field, an especially simple type of electromagnetic field produced by an electric charge even when it is not moving. The electric field produces a force on other charges in its vicinity. Electric potential, the capacity of an electric field to do work on an electric charge, typically measured in volts. Electric current, a movement or flow of electrically charged particles, typically measured in amperes. Electromagnets, moving charges produce a magnetic field. Electric currents generate magnetic fields, and changing magnetic fields generate electric currents. In electrical engineering, electricity is used for electric power where electric current is used to energize equipment. Electronics, which deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes and integrated circuits, and associated passive interconnection technologies. Electrical phenomena have been studied since antiquity, though progress in theoretical understanding remained slow until the 17th and 18th centuries. Even then, practical applications for electricity were few, and it would not be until the late 19th century that engineers were able to put it to industrial and residential use. The rapid expansion in electrical technology at this time transformed industry and society. Electricity's extraordinary versatility means it can be put to an almost limitless set of applications which include transport, heating, lighting, communications, and computation. Electrical power is now the backbone of modern industrial society. History. Long before any knowledge of electricity existed, people were aware of shocks from electric fish. Ancient Egyptian texts dating from 2750 BC referred to these fish as the thunderer of the Nile, and described them as the protectors of all other fish. Electric fish were again reported millennia later by ancient Greek, Roman and Arabic naturalists and physicians. Several ancient writers, such as Pliny the Elder and Scribonius Largus, attested to the numbing effect of electric shocks delivered by catfish and torpedo rays, and knew that such shocks could travel along conducting objects. Patients suffering from ailments such as gout or headache were directed to touch electric fish in the hope that the powerful jolt might cure them. Possibly the earliest and nearest approach to the discovery of the identity of lightning and electricity from any other source is to be attributed to the Arabs, who before the 15th century had the Arabic word for lightning applied to the electric ray. Ancient cultures around the Mediterranean knew that certain objects, such as rods of amber, could be rubbed with cat's fur to attract light objects like feathers. Thales of Miletus made a series of observations on static electricity around 600 BC, from which he believed that friction rendered amber magnetic, in contrast to minerals such as magnetite, which needed no rubbing. Thales was incorrect in believing the attraction was due to a magnetic effect, but later science would prove a link between magnetism and electricity. According to a controversial theory, the Parthians may have had knowledge of electroplating, based on the 1936 discovery of the Baghdad battery, which resembles a galvanic cell, though it is uncertain whether the artifact was electrical in nature. Electricity would remain little more than an intellectual curiosity for millennia until 1600, when the English scientist William Gilbert made a careful study of electricity and magnetism, distinguishing the lodestone effect from static electricity produced by rubbing amber. He coined the new Latin word electricus to refer to the property of attracting small objects after being rubbed. This association gave rise to the English words electric and electricity, which made their first appearance in print in Thomas Brown's Pseudodoxiae Epidemica of 1646. Further work was conducted by Otto von Guericke, Robert Boyle, Stephen Gray and C. F. Dufay. In the 18th century, Benjamin Franklin conducted extensive research in electricity, selling his possessions to fund his work. In June 1752 he is reputed to have attached a metal key to the bottom of a dampened kite string and flown the kite in a storm-threatened sky. A succession of sparks jumping from the key to the back of his hand showed that lightning was indeed electrical in nature. He also explained the apparently paradoxical behavior of the Leyden jar as a device for storing large amounts of electrical charge in terms of electricity consisting of both positive and negative charges. In 1791, Luigi Galvani published his discovery of bioelectricity, demonstrating that electricity was the medium by which nerve cells pass signals to the muscles. Alessandro Volta's battery, or voltaic pile, of 1800, made from alternating layers of zinc and copper, provided scientists with a more reliable source of electrical energy than the electrostatic machines previously used. The recognition of electromagnetism, the unity of electric and magnetic phenomena, is due to Hans Christian Ørsted and André Marie Ampère in 1819–1820. Michael Faraday invented the electric motor in 1821, and Georgo mathematically analyzed the electrical circuit in 1827. Electricity and magnetism were definitively linked by James Clerk Maxwell, in particular in his On Physical Lines of Force in 1861 and 1862. While the early 19th century had seen rapid progress in electrical science, the late 19th century would see the greatest progress in electrical engineering, through such people as Alexander Graham Bell, Otto Blathy, Thomas Edison, Galileo Ferraris, Oliver Heaviside, Ennius Jedlik, Lord Kelvin, Sir Charles Parsons, Ernst Werner von Siemens, Joseph Swan, Nikola Tesla and George Westinghouse. Electricity turned from a scientific curiosity into an essential tool for modern life, becoming a driving force of the Second Industrial Revolution. In 1887, Heinrich Hertz discovered that electrodes illuminated with ultraviolet light create electric sparks more easily. In 1905, Albert Einstein published a paper that explained experimental data from the photoelectric effect as being the result of light energy being carried in discrete quantized packets, energizing electrons. This discovery led to the quantum revolution. Einstein was awarded the Nobel Prize in 1921 for his discovery of the law of the photoelectric effect. The photoelectric effect is also employed in photocells such as can be found in solar panels, and this is frequently used to make electricity commercially. The first solid-state device was the cat's whisker detector, first used in the 1900s in radio receivers. A whisker-like wire is placed lightly in contact with a solid crystal in order to detect a radio signal by the contact junction effect. In a solid-state component, the current is confined to solid elements and compounds engineered specifically to switch and amplify it. Current flow can be understood in two forms: as negatively charged electrons, and as positively charged electron deficiencies called holes. These charges and holes are understood in terms of quantum physics. The building material is most often a crystalline semiconductor. The solid-state device came into its own with the invention of the transistor in 1947. Common solid-state devices include transistors, microprocessor chips, and RAM. A specialized type of RAM called flash RAM is used in flash drives and the more recently, solid-state drives to replace mechanically rotating magnetic disk hard drives. Solid-state devices became prevalent in the 1950s and the 1960s, during the transition from vacuum tubes to semiconductor diodes, transistors, integrated circuit and the light-emitting diode.